Second law summative. Experiment 1. How does acceleration affect force? Junior is a football player at GJHS. Junior wants to improve his ability to tackle larger opponents. Since his mass is 70 kilograms and he cannot change his mass drastically before the next game, he decides to practice increasing his speed off the line from a standstill. As Junior hits the high-end practice dummy, his force was collected. Coach Johnson records his acceleration for each trial. Junior's results were shown below. Trial 1, 70 kilograms, 4 meters a second squared, 280 newtons, force. Trial 2, 70 kilograms, acceleration is 5 meters a second squared, force is 350 newtons. Trial 3, 70 kilograms, 6 meters a second squared, acceleration, 420 newtons. There's the graph. Describe the trends in the data table for experiment 1. As the acceleration increases, decreases, remains constant, the force increases, decreases, remains constant, while the mass increases, decreases, remains constant. Which student hypothesis is supported by the data in experiment 1? Student 1, if the mass decreases, then the force will increase. Student 2, if the acceleration decreases, then the force will increase. Student 3, if the acceleration increases, then the force will increase. Student 4, if the mass increases, then the force will increase. At tonight's game, the force required to tackle the largest opponent is 350 newtons. What acceleration does Junior need to achieve to tackle him? 1 meters a second squared, 2 meters a second squared, 3 meters a second squared, 4 meters a second squared, 5 meters a second squared. Junior discovers there's a massive football player on Lakeside's team. He will need to hit the guy with 400 newtons of force to take him down. What must Junior's acceleration be? 6 meters a second squared, 7 meters a second squared, 9 meters a second squared, 12 meters a second squared. Newton's second law states that force equals mass times acceleration. Does the data from experiment 1 support this claim? So in your writing, state the claim correctly. Claim correctly supported or rejected with sufficient reason. Reference more than one data point or trend in the data. Use both numbers and units for all evidence. Refer to table and graphs by name when citing evidence. Experiment 2. How does mass affect force? 2 of Junior's teammates observe him conducting his experiment and want to compare their forces on the practice dummy. Junior, HG, and Giovanni record their masses on the table below. The students take turns recording each other's acceleration for each trial below. The practice dummy collected their forces. Trial 1, 70 kilograms, 5 meters a second squared, 450 newtons. Trial 2, 90 kilograms, 5 meters per second squared, 450 newtons. Trial 3, 110 kilograms, 5 meters a second squared, 450 newtons. And there's the graph. Describe the trends in the data for experiment 2. As the mass increases, decreases, remains constant. The acceleration increases, decreases, or remains constant, while the force increases, decreases, or remains constant. Which student hypothesis is supported by the data in experiment 2? Student 1, if the mass decreases, then the force will increase. Student 2, if the mass decreases, then the force will increase. Student 3, if the mass increases, then the force will decrease. Student 4, if the mass increases, then the force will remain constant. At tonight's game, the force required to tackle the largest opponent is 350 newtons. According to the data, which student or students should be able to tackle the opponent? Junior at 70 kilograms, HD at 90 kilograms, Giovanni at 110 kilograms, none of these students. At the Lakeside game, the force required to tackle the largest opponent is 490 newtons. According to data table 2, which student or students should be able to tackle the opponent? Junior at 70 kilograms, HD at 90 kilograms, Giovanni at 110 kilograms, none of these students. Newton's second law states that force equals mass times acceleration. Does the data from experiment 2 support this claim? Okay, you're going to want to state the claim correctly. Claim correctly supported or rejected with sufficient reason. Reference more than one data point, or trend in the data. Use of both numbers and units for evidence. Refers to the table graph by name when citing evidence.